So, as you might be aware, care at hospitals and care at home can be very expensive. With the increase in the population, now it's quite important to look into remote patient monitoring, personalized care, and assisted living. So this would benefit medicine, healthcare, and fitness sectors, and potentially many more. Page for Life was initially developed by CITC Ltd and then enhanced further through a collaborative project between CITC and Zinergy, funded by Innovate UK. Before I go into details of the Wear and Forget patch, I would like to introduce both of the companies. So CITC, which stands for Cambridge Innovation Technologies Consulting Limited, is a Cambridge-based startup, which was founded in 2014. Since then, as the name suggests, CITC's vision is to provide innovation and consulting services in high-tech fields that requires multidisciplinary approaches. So the CITC's vision consists of various research areas. One of them is smart biosensors and wearable devices, which I'm going to talk about today, as well as smart implants, molecular drug delivery systems, stem cells and gene therapy, in vitro diagnostic, and cell culture and self-growth. Zinergy is also a Cambridge-based startup, which was founded in 2015 by the graduates from the engineering department of the University of Cambridge. Zinergy's mission is to become the go-to solution for low-cost and flexible power behind Internet of Things and wearables. Zinergy's expertise is mainly on zinc-based battery chemistry, both in primary, which means non-rechargeable, and rechargeable secondary forms. Zinergy have the know-how to translate any battery chemistry, the conventional ones. We are not reinventing the chemistry here, but translating any conventional battery technology from those big cylindrical or pouch cells into thin, printed and flexible form. So specifically, Zinergy uses sheet-to-sheet and or roll-to-roll screen printing process, which is very well established and low cost. The battery manufacturing process itself doesn't require the control environment, as the zinc-based chemistry is water-based, so we don't need to conduct our production in a clean room or a controlled atmosphere. And the manufacturing process is highly customizable. And so the batteries can be made into any size, shape, voltage, capacity, and so on. So first of all, what Zinergy does is try to understand what customers' requirements are based on for a specific application, and based on that tailors the form factor and the specs of the battery or the energy storage module. So as I already mentioned, the cost of healthcare can be very high. The use of personalized wearable devices for long and continuous health monitoring is essential to keep healthy and prevent ourselves from any potentially serious health problems in the future. Well, of course, we are not the only ones who's been looking into this wear and forget patch concept. There are many other people who have been working on this. Several approaches have been proposed. Some of them are shown in this slide. And each of them actually is missing one of the essential features of wear and forget patch. Some of them are quite rigid, built on bulky substrates, or has to be worn on different locations of body to be able to collect the data. Some of them are limited by the reading range, while the others are limited by the operating time, meaning the energy storage module's lifetime. So here we have developed a wear and forget patch, which is a lightweight and a robust patch, which is around 15 centimeter by 4 centimeter. The thickness of the full system is around 1.5 millimeter and weighs around 4 grams. And it can be bendable up to a bending radius of 20 millimeter. So it has a set of sensors for environmental and motion sensing, such as light, temperature, humidity, pressure, and potential fall in case of any accident or health issues. So it's possible and easy to add or remove any set of sensors based on the application needs, as the device itself is built in a modular structure. Regarding the security, the patch operates with only its own infrastructure. The server manages the data securely within, under secure protocols within its own network. Also, as it is operated wirelessly, the patient or the user can move freely and can be monitored 24/7. So the patch has an off-the-shelf energy harvester called Rocky 100, UHF antenna, set of sensors, as I mentioned, that was temperature, light, humidity, pressure, and accelerometer, and energy storage module with some power management. Within the range of the base station, the energy collected through the energy harvesting system charges a supercapacitor. Here, to increase the voltage collected from the harvester, a booster is used so that we could use voltages as low as 1 millivolt. When the supercapacitor is charged above a certain voltage, then the rest of the energy collected through the energy harvesting system wakes the microcontroller up to run one of the sensors at a time, and send the data to the base station. So when the microprocessor is not talking to either the base station or the sensors, it goes into ultra low power sleep mode to conserve energy. Out of the reading range, obviously, the patch is powered by the battery. So in this case, the use of supercapacitor can extend the lifetime of the battery, as the supercapacitor itself can deliver a lot higher peak currents than the battery can do, but for a very short period of time, as its energy density is not so great compared to batteries. And also, the other advantage of using supercapacitor is that it can be rechargeable. So going into details of the energy module, the energy storage unit consists of a primary zinc carbon battery, which is printed thin and flexible. The zinc battery chemistry is quite safe. It's water-based, electrolyte, it's disposable and environmentally friendly. The single cell of zinc carbon can deliver 1.5 volts OCV, and also the aerial capacity is around 2 milliamp hour per centimeter square. The printed supercapacitors uses pure carbon electrodes, and hence the energy storage mechanism is purely double layer separation. So the numbers of charge in this charge cycles is quite high, around 10,000 cycles. The supercapacitors gives around 100 millifarad per centimeter square and operates at a voltage of 2.5. So in this slide, it shows the available power in dBm versus the distance between the patch and the base station versus the radiated power allowed by the regulations. So as you can see within these limits, the patch without the battery can operate at a distance ranging from 2.3 meters to 3.5 meters at full power. And this can be extended up to 5.9 meters at low power. And when the battery is incorporated, the range can even extend it further to 8.9 meters. So this is a desktop user interface developed to monitor the parameters. So it's got the humidity, light, temperature that you can click on and monitor the live data. And also you can actually monitor the individual users or patients identified by the unique tag IDs. This is the mobile version of the software, just to make the whole system more mobile. So to wrap up, this wear and forget patch for assisted living helps us to understand users' daily routine, and any sudden changes in the pattern would alert the system and let a health professional or a relative know about the users or patient to avoid any serious emergency